So the next thing that we look at is something that is called cumulative probabilities. Okay, cumulative, we've already come across that word. It means how things are kind of like adding up as you go. So often, we wish to find the probability of a range of values. Like we were talking about with the dice in a previous example, what's the probability that you get 1 or less 6s, or 5 or less 6s on a dice? For a binomial distribution, this was relatively easy if the range was narrow. For example, if we were saying what's the probability that the random variable x is less than or equal to 1, we could find out the probability that it was equal to 0, the probability it was equal to 1, and add them together, because we're saying it's either of those two things added together. But it would be much more computationally expensive if we wanted to say the probability that x is less than or equal to 6. What do you think I mean computationally expensive? Andrew?
Basically, how long it takes.
How long it takes. And it's computationally expensive because it would use a lot of a computer's energy. It would use a lot of time to work it out. Now, if we were going to do it the long way, the probability that x is less than or equal to 6 would be the probability that x was equal to 0 plus the probability that x was equal to 1 plus the probability that x was equal to 2 plus, etc., the probability that x was equal to 6. So we would have to get 7 probabilities and add them all together to find out the probability that something was 6 or less. But we're going to try and now find out, we're going to show you the way that you can do it on your calculator and how you can do it using the tables. You may think, oh, I've just got a calculator, I'm just going to use my calculator the whole time. But the tables that I've given you that can be found in the formula book and in the textbook and on this printed sheet that I've given you, they are going to be really useful for what we learn about in the next chapter. So I want to make sure that we can do all of these different things here. So we're going to say, I want to find the probability that x is less than or equal to 6 if x is binomially distributed, there are 10 things in the trial, and it is 0.3. So here are some instructions here, but I'm actually just going to do it on the camera as well. Okay, so I'm going to grab my... I'll start off with the ClassWiz calculator. I know most of you have got the graphics one, but we'll show you this one too. So the difference this time, you go menu, number 7 for distribution. Instead of using the binomial PD, we now use CD. What do you think the C stands for? Cumulative. So we press number 1 for the binomial CD. We press variable rather than list. And in our example we were doing, we said there were 10 things. The probability was 0.3. And x is equal to 6. Okay? So you should get the answer 0.9894. Okay? 0.9894. Now I'm going to show you how it works on the graphics calculator. So on the graphics calculator, you go to statistics, which is number 2, distribution, binomial, and again you press binomial CD, okay? Binomial CD for cumulative. Now the thing that makes the graphics calculator better here is that you can decide what the upper and lower values are going to be. So I'm going to do number of trials is 10 and the probability is 0.3. Now we wanted it to be less than or equal to 6. So the upper boundary is going to be 6 and the lower boundary is going to be 0. So this is the graphics calculator's advantage. You will be able to decide what the lower and upper boundary will be. And we should get the same answer of 0.9894. You can see that those are exactly the same as each other. Okay? The last thing that I want to show you how to do is how to use the tables. So grab your green pieces of paper that I've given you today, and I'm going to show you how you use these. These are in the formula book. They're also in the textbook as well, and I can give you a PDF of this too. So these are a little bit harder to use, but they have got some advantages because on a calculator, you can just see one answer at a time. And some problems, you want to see lots of different answers to decide what's the one you're going to pick. So the way that you use this table is running along the top are the different probabilities that you've got here. And then running along the side are the different values of n. So we've got n is 5, n is 6. And there's many pages of this, going all the way up to n is 30. And on the very last page, n is 50. So the advantage of the calculator is you can put in any numbers at all and any probabilities, Whereas the ones in the table have got fixed probabilities. They have to be these ones here, and you have to be able to do it with the values of n that they get. So the calculator has got some advantages, but I quite like these paper versions for certain things too. So what you're going to do is you're going to try and locate the area where it says that n is equal to 10, which is this bit that we've got here. You're going to find the probability at the top of it being 0.3, so it's this column that I'm going to run my finger down here. And then you're going to find where it says that x is equal to 6, and you get the number 0.9894. Hopefully you can all see that on your tables. So we've now got 1, 2, 3 different ways of the same answer. Okay? That's how you use the tables. One thing I want to make you aware of, the class whiz calculators, so the non-graphics calculator, always does the x is less than or equal to n. Not using the same values that we've got here, really. I'm saying, like, if it's x is less than or equal to 6, the value that you type in for x is always using this inequality symbol. It's always inclusive, rather than it's less than or equal to the one above. So here, when we wanted it to be less than or equal to 6, we were allowed to put 6 into the calculator, okay? It never does this symbol. It always does this symbol.
X is less than 6, we put 5.
Good. If it asked us for x is less than 6, you would actually put a 5 in on the calculator, because the calculator is always going to do it with less than or equal to. The graphics calculator can choose the upper and lower limits, but the upper and lower limits are always inclusive. Okay? They always are using these inclusive symbols, and the calculator is never using these symbols. So if you have a question that has got these symbols, you will need to translate it so that the calculator realizes that it has an or equal to sign in. Okay? And we're going to practice doing that right now. So we have got 3 of these things here that we want to work out. The first one is going to be pretty easy. I want you to decide which method you want to do, either the table or your calculator, to find out the probability that x is less than or equal to 7. I'm going to do mine on a calculator. No, I'm going to do mine on a table. So we're going to do 20 and 0.4.
So n will be 20.
So n is 20 and p is 0.4.
Is the upper 7?
And the upper is 7. There is a 0.4 for the probability running along the top.
0.415.
So you think you've got it? There's my 0.4. And for 7, it's 0.4159. And from your calculator, I'm sure you'd have the same thing, okay? 0.4159. Yeah, so now the next one, if you did it one of them on the tables, we should now try the next one using the calculator. So if we're going to be using the calculator, I think we need to rewrite this one in a slightly different way. It's going to be rewritten as less than or equal to 5. So you can now look up that one.
Is this given in the exam?
This is given in the exam, yep. So less than or equal to 5, I'm going to go do mine on my calculator this time. I agree, you got 0.1256 to 4 decimal places. Yeah, so we need to think, because this one's asking us something different, isn't it? This one is saying, what is the probability that the random variable x is greater than or equal to 15? So I'm just going to jot something down here, right? We actually want it to be the values which are 15, 16, 17, 18, 19, and 20. So what do I need to do here, do you think, to find these ones? So I'm going to do something with the lower one. I'm going to find out the probability that x is less than or equal to 14. I'm going to find out the probability of these missing ones that I've got down here. But then how would I find the probability of the ones that I actually want?
Probability of less than or equal to 20.
Not, what did you say, sorry?
Less than or equal to 20.
Yeah, less than or equal to 20. Do you know what is the probability that it would be less than or equal to 20?
1.
1. Because the probability if there's 20 things is going to be 1. The probability that it's less than or equal to 20, well, it's obviously going to be less than or equal to 20 because we're only doing it 10 times. So yeah, actually, if you want to, what you could think about the first way of writing it, we're saying it's the probability that it's less than or equal to 20 minus the probability that it's less than or equal to 14. So we're saying we've got all of them, and we're removing the ones that are lower than 14 or lower. But really, that is just 1 minus the probability that x is less than or equal to 14. So we're going to look up this one here, and then we'll do the subtraction of it, okay? I'm going to look this one up on the calculator for a second. So I'm going to change it so that x is 14, and my number that I get is 0.9984. There is a way that you can transfer it across. I need to double check how you do that, but you just need to just jot it down, and then it's easier then to kind of do a subtraction. Now, there is a quick shortcut about how to do this subtraction just in your head, okay? The way that I do this shortcut is when I subtract them, I want to find the numbers that will make these three add up to 9, and then the last one, it will add up to 10. So it will be 0. Well, that's already added up to 9. That's added up to 9. I need a 1 for that, and then a 6 for that bit there. You can just do it on your calculator as well. But the answer is 0.0016. Now I'm going to show you how you can do this one on the graphics calculator without even having to do the statement that's here, which is rewritten. So most of you do have the graphics calculator. So let's switch over to my camera. We're going to change it so the number of trials was 20 and the probability was 0.4. Now, for this one that we've got here, we wanted to say that it was going to be greater than or equal to 15. So this time the lower boundary is going to be 15, and the upper boundary is going to be, what would the upper boundary be? Yeah, let's get that focused a bit better. Maybe it's because of this. That's better. So what should the upper boundary be? 20. So the graphics calculator you don't even need to do the 1 minus. You can just go straight in and do 15 to 20, and you should get, that is 0.0016, because it's in standard form. This e minus 0.3 means times 10 to the minus 3. So this thing here is 0.0016. So there's a few different methods about how we might go about doing this. So we've got a couple of them here. Let's have a quick go at doing these ones. I'm going to do these ones with you as well, but try and keep up with them. This time, we've got 25 for our random variable. We're using the letter m because it doesn't always have to be x, and the probability is 0.25. Now, the first one, we're trying to say, what is the probability that m is greater than 20? So let's just do this one over here. The probability that m is greater than 20. Now, what I like to do is I like to jot down the numbers that it's actually referring to. So being greater than 20, which ones are we actually interested in? What numbers would we... 21, 22, 23, 24, 25, okay? So if we want it to be greater than 20, you're going to do 1 take away the probability that m is less than or equal to what? 92. No, look, we want to remove these ones. Which are these ones that we're removing? We want to remove the 20 or less. So we want to remove the ones that are below or equal to 20. Remember though, if you've got a graphics calculator, you could type this in a different way. You could just type between 21 and 25 on your graphics calculator, and it would give you the answer straight away. But I'm going to do it the way that we have here. So we're going to do less than or equal to 20. So it's 25 and 0.25. And 20 gives me 0.9999. So basically, very, 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 very high. So it's 0.9999. Not a very good example. It's basically going to be 0, isn't it? So not a very good example that I've picked there. Okay, let's go with that one then. So if we try it on the graphics calculator, greater than 20, that's 21 to 25. So that means that there are 10 zeros, 0.00000000009676. So it's incredibly small, okay? So we're not going to worry too much about that one. Now we're going to try this next one, that the probability is between 6 and 10. Now, my advice for this, is to jot down the numbers it's actually talking about. What is the numbers it's actually talking about? 7, 8, 9, 10. So if you have a graphics calculator, the upper and lower are going to be 7 and 10. If you don't have a graphics calculator, how would we work this one out? How would we get just these values here? First of all, we want to remove lots of these values down here. So I know I'm going to want to remove being less than or equal to 6. I'm going to take those away from the list. What would the start of the list be if I want all of these ones to begin with? I want it to be less than or equal to 10. This list here is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And I want to remove the 6, 5, 4, 3, 2, 1, 0 so that I'm left with 10, 9, 8, 7. Okay? So I'm going to get both of those on the calculator, and then I'll check it with the graphics one as well. So this time we're going to do 10 and 6. So 10, you get 0.97033. 6, we get 0.56109. 0.56109. And then we actually just do that subtraction, which is why you can see the graphics calculator is a big time saver. And to 4 decimal places, I've got 0.4092. Confirming that on the graphics by just doing it between 7 and 10, I can just put in 7 and 10, and I get 0.4092. So I think if you do have the graphics, it's very easy. If you don't, it's okay. Now, even if you do have the graphics calculator, so special attention for those of you that do, you do need to make sure that you understand how to do this thing that we've got here, because certain problems you will be forced to rewrite statements in these kinds of ways that we have, okay? So what I'm going to ask for us to have a go at now is not to actually find any probabilities, but just to think about how we would rewrite them in terms of cumulative probabilities. In other words, rewriting them in statements that look like this, okay? So we're going to try some of these together. My top tip for these is underneath, write down the numbers that it's referring to. So for this first one that it's saying it's less than 5, it's referring to 0, 1, 2, 3, and 4. So clearly, this is the same as it being less than or equal to 4. The next one that we've got is greater than or equal to 7. So it'll be 7, 8, 9. I'm going to put ... because we don't actually know where that one is going to stop. What would that one be in terms of the cumulative probabilities? Pardon? Not the same, because we don't. The calculator can't do this. Pardon?
X is greater than 0.
We can't do greater than or equal to. The calculator only knows how to deal with less than or equal to. So the 1 minus the probability that x is less than or equal to x. Remember, 1 represents all the values. The subtract means remove. And this one means the ones that are 6 or less. So we take all the values in the list. We are removing the ones that are 6 or less, which leaves us with the 7, 8, 9, 10, all the ones that are bigger than 6. So what about this next one where it's greater than 7? What would my numbers be in the list?
1 minus p, x less than 7.
It would be 1 minus the probability that x is less than or equal to 7. I'm going to just do a list of red numbers first of all. Being greater than 7 is talking about 8, 9, 10, 11, etc. 1 is all of the numbers in the list going up. We don't know how many numbers are in this list because I haven't told you what n is. And we are removing the ones that are less than 7. or sorry, that it's 7 or less. Whoops. This one, I do like to jot the numbers down that go in between. So it says it's between 10 and 20, but it doesn't include 20. So it's 10, 11, 12, 13, all the way up to 19. So what should be the first thing that I would write for this one?
10. B equals 10.
No, not 10. For the probability that x is less than or equal to 19, which is talking about 19 or below, I want to remove which ones? Below 10. How do I say below 10?
Including a less than.
I'm only allowed to use these symbols. So what? Not 10. 9. I want to remove the 9s or below. You're only allowed to, in these bits I'm writing in blue, you're only allowed to use the or equal to sign because that's what the calculators and the tables is thinking in. Okay, we've got between 1 and 8. So that's in terms of the numbers. 1, 2, 3, all the way up to 7. So what's our first probability going to be? Less than or equal to 7, because we want the list to be 7 or below. What do we need to remove from this? The 0 one, which is the probability that x is equal to 0. The probability that x is equal to 0 is the same as that, right? Less than or equal to 0. Because you can't get less than 0 in this. Obviously, you could put these in your graphics calculators in other ways, but I just want to make sure we know these alternative ways of writing them. Okay, let's see if we can go a little bit quicker for this one. This one's between 10 and 20 inclusive. In other words, it's 10, 11, 12, 19, and 20. Anyone think they can go straight in and tell me what this would be?
Less than 20 minus less than 10.
Good. Less than 20 minus less than 9. Because if you remove the less than 10, you'd be removing the 10 as well. What about this one? Being equal to 100. Obviously, we could use the PD bit of our calculator, but we're now going to see, can we find what it's equal to 100 just by using the cumulative part of the table? So if we're going to just say we want it just to be 100, how could we find out that? Andrew?
Dx is less than or to 100 minus dx less than 99.
Yeah. Less than or equal to 100 is 100, 99, 98, 97, all the way down to 0. Less than or equal to 99 is 99, 98, 97, all the way down to 0. So if you subtract them, you just get left with the 100. Obviously, you could type it into your calculator and just find out the PD part of it that you've got. So now we're going to be doing between 20 and 30. Does it include 20 and 30? No. So it's 21, 22, all the way up to 29. So we want our list to start at less than or equal to 29. And which ones are we going to remove? 20? I agree. We're going to remove the ones that are 20 or below so that we have left in the middle 21 to 29. Now we've got some that come in words because they love these kinds of questions to come in words. So let's see first of all if we can translate this. The probability that it is at least 30. Okay, so obviously I'm going to have x and I'm going to have 30. What symbol should go in here?
X is less than or equal to 30.
No, at least.
At least saying that x is got to be bigger than 30. Because if I said 35, that's at least 30, isn't it?
Minimum 30.
So it's saying the minimum is 30. Is it allowed to be equal to 30?
Yes?
Yes, so it's saying x is greater than or equal to 30. At least 30 means 30, 31, 32, 33. It means things that are getting bigger. 30, 31, 32, etc., etc. How did we find out that one in terms of probabilities? We want all of them, but we want to remove some of them. 1 for all of them minus, which ones are we removing? The 29. Remember this thing here means all the values. That one said at least 30. This one now says greater than 30. So what's that going to look like here? The probability that x is
This is the greater than.
just the greater than sign, no equal to. At least means it includes, greater than means it's not included. So this one is going to look very similar, apart from this time it's going to be 31, 32, 33, all the way up to the end of those values. The reason I don't know the end of the values is in these questions I haven't told you what n is. So this one would be 1 minus the probability that x is less than or equal to 30 in this case, okay? So I'm going to ask you to have a go now at exercise 6C, questions 1 to 6. If you have got the graphics calculator, I would be happy for you to type this kind of thing in directly, where you would just say the lower bound is 10 and the upper bound is 19. One last thing I'm going to say about if you have the graphics calculator is the PD bit is basically useless now. If you have the graphics calculator, I would advise you to use the CD bit all the time. So let's say I wanted to find out the probability that it was equal to 7. I could make the lower 7 and the upper 7, and it would give me the answer of it being equal to 7. Just remember that number for me 1 second, 0.1654. I'm now going to go back and do it in the PD section, and I'm just going to make it equal 7. And you do get 0.1654. So if you just always want to use the cumulative one, make sure that you're just careful about what you put in for the lower and upper. If you don't have the graphics one, if you've got this one, you'll need to make sure that you're doing the PD for it being equal to and the CD for it being less than or equal to. You may also like to have a go at using some of the tables when we do these questions as well, okay?